Good morning, everybody. Today is Monday, October 17th, 2022. I am Man with Blinking Lights, and today we're going to be doing some more Exercism in the Elixir syllabus. So I believe today we're going to be looking at links and tasks as we work towards the RPN calculator inspection exercise. So with that done, let's just get right on into it. Elixir processes are isolated and don't share anything by default. When an unlinked child process crashes, its parent is not affected. The behavior can be changed by linking processes to one another. If two processes are linked, a failure in one process will be propagated to the other process. Links are bidirectional. Processes can be spawned already linked but to the calling process using spawn link, which is an atomic operation, or they can be linked later with process.link. Linking processes can be useful when doing parallelized work, when each chunk of the work shouldn't be continued in case of another chunk fails to finish. Trapping exits. So linking can also be used for supervising processes. If a process trap exits, it will not crash when a process to which it's linked crashes. Let me read that again. Linking can also be used for supervising processes. If a process trap exits, it will not crash when a process to which it's linked crashes. That reading's a little weird. It will instead receive a message about the crash. This allows it to deal with the crash gracefully, for example, by restarting the crash process. A process can be configured to trap exits by calling process.flag trap exit true. Note that process.flag returns the old value of the flag, not the new one. That's interesting. The message that will be sent to the process in case a linked process crashes will match the pattern exit from and reason, where from is a PID and reason is anything other than a atom normal. That means the process crashed or was forcefully killed. Okay. Some of the reading there is a little suspect, but okay. So that's links, and then next up, to accomplish RPN calculator inspection, we need to talk about tasks. So tasks are processes meant to execute one specific operation. They usually don't communicate with other processes, but they can return a result to the process that started the task. Tasks are commonly used to parallelize work, async/await. To start a task, use tasks.async. It takes an anonymous function as an argument and executes it in a new process that is linked to the caller process. It returns a task struct. To get the result of the execution past the task struct to task.await, it will wait for the task to finish and return its result. The second argument is a timeout in milliseconds, defaulting to 5,000. Note that between starting the task and awaiting the task, the process that started the task is not blocked and might do other operations. Note that between starting the task and awaiting the task, the process that started the task is not blocked and might do other operations. Okay. Any task started with task.async should be awaited because it will send a message to the calling process. Task.await can be called for each task only once. That makes sense. Start link. If you want to start a task for side effects only, use task.start or task.startLink. Task.start will start a task that is not linked to the calling process, and task.startLink will start a task that is linked to the calling process. Both of these functions return an OKPID tuple. Okay. So that's a lot to take in. Do I have anything to say? I don't think so. Okay, we'll just get started here. So your work at Instruments of Texas on an experimental RPN calculator continues. Your team has built a few prototypes that need to undergo a thorough inspection to choose the best one that can be mass produced. You want to conduct two types of checks. First, a reliability check that will detect inputs for which the calculator under Inspection either crashes or doesn't respond to, or I'm really reading, either I'm reading tough today or these are written tough today. Firstly, a readability check that will detect inputs for which the calculator under inspection either crashes or doesn't respond fast enough. To isolate failures, the calculations for each input need to be run in a separate process. Linking and trapping exits in the caller process can be used to detect if the calculation finished or crashed. Secondly, a correctness check that will check if, for a given input, the result returned by the calculator is as expected. Only calculators that already pass the reliability check will undergo a correctness check, so crashes are not a concern. However, the operation should be run concurrently to speed up the process, which makes the perfect use case for asynchronous tasks. Okay, so, all right. So we're going to download our example, and we'll run it in VS Code. Copy CD code. Bring that on over. And then we've got our core module. And then we've got our test file. And then we've got our README. And I'll hide my source list. Okay. Okay. And our comes. Task 1. Start a reliability check for a single input. Implement start reliability check function. It should take 2 arguments, a function, the calculator, and an input for the calculator. It should return a map that contains the input and the PID of the spawned process. The spawned process should call the given calculator function with the given input. The process should be linked to the caller process. Okay. That would just be like start link, right? And that would take any function. Function and then inside of that, so calculator is the function, and then that's the input, and it returns like okay PID. Is that what it was? Implement start reliability check. It should take 2 arguments, a function, the calculator, and an input for the calculator. Should return a map that contains the input and the PID of the spawn process. Oh, okay. So it should be something like this. So input is the input, and the PID is the PID. And what are you complaining about? Will never return since the typing is blah. Oh. Oh, okay, that returns okay PID. Okay. Are you still complaining? Yeah, I think that's just the staleness. Alright, let's try to run the tests. Run all tests. They fail, and they take a long time to fail. Okay, so let's run this one. Run test a cursor. Start link. When is function? Okay. Start and start link. Documentation task module. What am I? Function Oh, I guess it's not. It's just that you don't need you don't need to not collect argument one because there's no argument one. That makes sense. Okay, so let's run that test again. Okay, that looks good. So let's run all the tests in the Explorer. And this might take a little while because we're doing like asynchronous work, and these tests are going to wait for things. And I think the default wait is like 5 seconds. So yeah. Okay, so task 1 is green, green. Task 2 is red. Okay. So task 2. Let me close this. Interpret the results of the reliability check. Implement await reliability check result function. It should take 2 arguments. The first argument is a map with the input of the reliability check and the PID of the process running the reliability check for this input, as returned by start reliability check. The second argument is a map that serves as an accumulator for the results of reliability checks with different inputs. The function should wait for an exit message. If it receives an exit message, exit from a reason with the reason normal, from the same process that runs the reliability check, it should return the result map with the value OK added under the key input. It receives an exit message with a different reason from the same. Somebody's backing up. It receives an exit message with a different reason from the same process that runs the reliability check. It should return a result map with the value error added under the key input. Okay, if it doesn't receive any messages matching this criteria in 100 milliseconds, it should return the result map. The value is timeout added under input. Okay. When an exit message is waiting for the process in its inbox. Oh boy. Okay. Alright, what do you want me to do here? Awaits a task reply and returns it. Awaits a task reply and returns it. The return is term. So in this case, it returns 2. I really wish the concept documents of here would have more examples. Like it talks about the abstract idea, but then like it doesn't show it to you, which like it really should show it to you. To get the results of the execution, pass task struct to task.await. I mean, I get like, I mean, they kind of leak what they want you to do. They want you to wait for it here. But how do I... This is very, feels very just like abstract and not very well structured example. So task async, and maybe this is where I'm screwing up already because I'm doing task start link, and task start link returns okay PID, because I did that because it was asking for the PID, but like I mean, the fact that this example requires both the link and task, I'm not sure if they wanted me to do start link there. Regardless, I mean, like, you have a PID, but you can't call dot task dot await with a PID. So starts a task as part of a supervision tree for the given function. It's weird because like start link, like these both return PIDs, which is where I went to that because it was asking for PID specifically in the input. But later, like if you're supposed to be awaiting tasks, like you want a task struct, you don't want the PID. Two arguments. I mean, the fact that this thing is so long is like kind of a smell that like this is a lot of stuff. And it's at the end of the syllabus, I get that. Like this is more complex like Elixir process stuff, but like I mean I've done task before. Like I understand what kind of task is. I'm just trying to understand what they want me to build, and that's like throwing me through a loop here. And maybe just it's Monday and I'm grumpy for other reasons, but the function should wait for an exit message. How does this function wait for an exit message? Linking can also be used for supervising processes. If a process trap exits, it will not crash. When a process to which it's linked crashes, it will instead receive a message about the crash. This allows it to deal with the crash gracefully, for example, by restarting the crash process. A process can be configured. I mean, do they expect me to be writing like handle like info on this module? But like, I mean, obviously they haven't done that. Wait. If it receives an exit message, doesn't receive any messages, it should return the result map. Uh, I'm really thrown by the fact that the only thing that so far they've taught me about waiting is task.wait. And I can't call task.await from here because all I have is the PID. Like, there's no task structure that, like, I can't, like, generate a task struct from a PID, right? I mean, it contains those. Start, likely, yield many. Alright, I'm going to cheat. I guess that's fine because it's like the task hasn't started yet. I should, I'll show you what I'm looking at. So this solution here, they use task.startLink, and then they have the PID, and then inside a wait reliability check, they just start receive, loop, looking for messages in the mailbox. And so this kind of makes sense because like the solution to this, like you don't have to like start listening. You don't have to start looking in the mailbox before this sends. Like this will happen, and then if something goes wrong, um, you know, in theory, I guess it would put stuff in the mailbox, but like it's not lost because the mailbox is always there. I would think. Although that begs the question of like task.startLink, like when it accomplishes this, when it finishes the work of this function, like doesn't the process like stop? Like it's not clear to me. I don't really have in my head of like I don't really have it in my head of like how these what the expected order of this is like. So when I look at this test, uh like it's simulating like it's like I don't understand the relationship between this function and this function in a real world scenario. Like the fact that they have all this setup code that like they're just putting stuff in the mailbox, like that's like I don't get it at all. I don't know why this is built this way. Like this example is really confusing. And I understand like why this solution works. Like if you know the test is just shoving stuff in the mailbox, they're like, okay, well let me just look in the mailbox and return stuff. But like that's weird. All right, let's keep going. So if the mailbox contains, this is such arbitrary stuff. Um, normal, and then the return value is yeah, just like putting stuff in the accumulator, which is the result thing. Result input. Should that be an atom? Shouldn't that be an atom? Under the key input. Yeah, none of them have that. Map put results. Like, I would think it would be that. But that's not what other people have. That is weird. Okay. So exit. And it's also weird because like we never configured this process to like trap this way. So like they taught us in the concept doc of like, oh, you need to, you know, tell the process to do this kind of trap thing, and like we're not doing that in any of our code. To like, so I don't know. I don't know. Results input. I want to use it as an atom, but I error. And then they did an after to throw the but put the timeout. Results input singular timeout code. All right, I'm gonna run the tests. I think I'm just cranky today too. Like I don't know. It's Monday and I have some client work and I'm really blocked because I haven't been given access to the repos and stuff yet, so I'm kind of annoyed. Alright, this fails. I'm gonna run at cursor so I can see the failure. And yeah, it's looking okay, it's looking for the input as the key. Not this atom input stuff. Okay. So we'll run all the tests at cursor. Oh, come on. Green, green, green. Green, 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 green. Red, task 3. Task 3, run a concurrent reliability check for many inputs. Implement reliability check function. It should take 2 arguments: a function, the calculator, and a list of inputs for the calculator for every input on the list. It should start a reliability check in a new linked process by using start reliability check. Okay. Then for every process started this way, it should await its results by using await and reliability. Okay. Before starting a process, the function needs to flag the current process to trap exits to be able to receive exit messages afterwards. It should reset the flag to its original value. The function should return a map with the results of the reliability checks of all the inputs. Okay. Alright, I feel like now that I have this process flag, I am just cheating like crazy. So we're gonna change the trap exit value, trap exit, to true. And like it said, the return value is going to be the previous value. So then at the end of this, we can say, you know, process dot flag trap exit, and then, you know, the current is a little weird. That's a weird name. previous? Should it be? Initial process flag. Okay, so we'll grab the initial, we're going to get the initial process flag value, and then we'll set it up at the end. Okay, and then in our stuff, we have to take all the inputs and then map them to the results. Dot map. Function input. Start reliability check. Calculator. Calculator. And then the input. So that'll take a list of inputs, right? Yeah, a list of inputs, and then it'll map them to a bunch of maps that are basically the input and the PID. And then once you have that, you do enum.map, and you iterate over those, which they don't have a good name, which is unfortunate. So we'll just say M. And we don't want to map them, we want to reduce them. Oh, we're gonna reduce. Okay, and then we'll start with an empty map. Yeah, the names here are really bad. Like this is a problem. Anytime you have just like arbitrary maps, I mean, what do you call them? Like if you don't have nouns for stuff, like it gets really hairy. Again, I'll just say M. Data and accumulator. Okay, so wait reliability check, and that'll just take M in the accumulator. Oh, we're gonna pass this map into there so we can. Ooh, this is so ugly, so ugly. I am not happy here. I'm not happy at all. Output? Jesus Christ, this is ugly. And then we'll return the output here. Oh, that is nasty. I want to get out of here. I want to finish this and just get out. Run all tests. Oh, man. Okay. So this is going to accept this, calculator, and then these inputs, and then it's supposed to return this map, which shows you for each input the result it got by spawning a task. Wow, this is just so. Oh, all right, I'm done. I can't just sit here and complain about it all day. We'll do task 4. I'll just get the hell out of here. Implement correctness check. It should take 2 arguments: a function, the calculator, and a list of inputs. For the calculator, for every input on the list, it should start an anonymous task that will call the calculator with the given input. Then for every task started this way, it should await its result for 100 milliseconds. Correctness check. It accepts the calculator, accepts the inputs, and then it just returns a list of return values. Okay. So similarly, you start with the list of inputs, and we want to transform those into a list of tasks. So we'll do enum.map, and then we'll say function I for input, and then we'll do task.async, and this is just going to be an empty, no argument, anonymous function that runs the calculator with the input, and it ends, and gotta end the map as well. So this is going to take the inputs, going to create a whole collection of, because task.async returns. Task.async returns the task. Yeah, that makes sense. Okay, and then we'll just we'll wait for them. I'll wait them. So yeah, so enum.map, and it's just going to accept a task, and we'll just say task.wait, and we'll pass in our task, and we'll also pass in 100 milliseconds for the timeout value, and then we'll end, and what are we doing here? Function task, await. What don't you like? Oh. Okay. Then we'll run all tests in the Explorer. All right, let's see. Next test. They work. Exercism, submit. RPN calculator inspection. Hopefully the robots are happy. Robots are not happy. They have one thing to say. Check the comments for something. Preferred capture notation. Yeah, I mean, I get it. Like right here where we say reduce and we accept a mapping in the accumulator, and then we call await responsibility check and we pass it the map in the accumulator. Like, in theory, you could just do it like that. Which I don't know. Does that still work? Test. Yeah, it still works. I don't know if that's as readable. That's fine. I'll submit it. Make the robots happy. Because my life is about pleasing robots. Okay, that's done. Let me look at the community solutions. Yeah. Trap. Tap. I don't like that because, like, it makes it feel like this line is connected to the transform that's going on, and I don't really like that. Yeah, and they do a thing similar where they just do capture stuff. Okay. Alright, I'm gonna finish this up. I don't know why I'm particularly grumpy today, but this exercise did not gel for me at all. I just feel like it's really obscure. And the fact that, like, I don't know, it didn't work for me. So, So we cheated, and we're going to publish our cheating. And we finished links and tasks. And we've got one more to go. We've got Gen Server. And hopefully this final example will put me in a better space than this one did. But that will have to wait for another time. Thank you for watching. Hopefully you got some value out of this. And if you have any questions or feedback, let me know. Other than that, have a good day. Have a better day than me doing this example. And we'll see you next time. Bye-bye.